Great, let's get started. This is logic coding. Today we're going to look at LeetCode 56, merge intervals. It's a classical interval-related problem, and it's going to be our first for this series. So the problem asks us, given an array of intervals, so it's a vector of int, while each interval has a starting integer value and an integer value both included, and asked to merge all overlapping intervals and return another array of non-overlapping intervals that cover all the intervals in the input. So the idea is pretty straightforward. Let's take a look at the example 1. If we have the original interval is 1, 3, and then 2, 6, 8, 10, 15, 18, ask us to merge all the overlapping intervals. So 1, 3 and 2, 6 are overlapping, and the merge intervals will become 1, 6. 8 and 10 is not overlapping with 1, 6, so it's just going to be appended after this. The same with 15 and 18. And if we have another example would be 1, 4 and 4, 5. Obviously, it's overlapping with a 4 because both are included, so the merge will become 1, 5. A natural way to think about those things is actually to draw, use a pen and paper to draw the intervals from left to right and basically see the merger pattern. So the way to think about this is always to draw those intervals, right? And then if we want to merge another, we just basically do something like this. So normally it would work better if we have sorted intervals according to start value. Because if we have this, then we would, if we have two interval, and we know that A is smaller or equal than C, we can just compare B and C. If B is and C, then no merge needed. Otherwise, the merged interval will become A and max of B and D. So what we can do is we can first sort the list, sort the intervals, and then do a linear scan of intervals. If it satisfies if it's no merge needed, we just append the new interval. Otherwise, we merge the last element of the merged matrix. So let's see how we will write the code. First step is we sort the intervals. And let's create a merged. Then let's do a linear scan of the intervals. If at the first it's empty, or B is smaller than C, we directly append, push back this interval, else we merge it. We just update the last element into max element with, so basically we just update the second element, the end interval between B and D. That should be it. Let's run the code. merged empty. Okay, back 1. Cool. So the time complexity will be dominated by the sorting algorithm, which will be O and log n. While we do a linear scan, but it's only gonna take us O n time, so the time complexity would be O and log n. And the space complexity, since we allocated a merged array, so it's going to take O n time. Let's submit it. Perfect.